Good afternoon and welcome to Webinar Wednesday. We're excited to have 200 registered attendees for today's webinar, which is eligible for 1 credit from the ACI. Let's get started today by giving one lucky attendee an ice cooler for answering this trivia question. Missouri, along with Tennessee, are bordered by how many states? You can answer now using the questions feature on your dashboard. While you're answering, I want to invite everyone to join us for our 4th Imaging Conference and Expo, which will be held July 24 through 25 at the Hyatt Regency Hotel in Reston, Virginia. The ICE conference will bring 400 plus imaging service professionals from across the nation to Washington, D.C. for 2 days of learning, networking, and the latest advances in imaging. Registration is open now. Receive complimentary admission by using the VIP Pass Compliments of Universal Medical, which can be found in your Webinar Wednesday workbook. Details can be found at attendice.com. All right, and our winner of our ice cooler is Taylor Martin. Congratulations. The correct answer is 8. Webinar Wednesday would like to thank our sponsor, Universal Medical. Universal Medical has nurtured a business philosophy founded on offering comprehensive nuclear medicine equipment services at a reduced price. Universal Medical's products and services include new and reconditioned nuclear imaging systems, quality parts, excellent equipment service, training courses for healthcare technology managers, camera system moves, technical and clinical support, flexible financing options, and more. Visit uni-med.com for more information. Our presenter today is Craig Snodgrass, National Service Manager for Universal Medical. Craig, you may begin whenever you're ready.
Thank you. Good afternoon, everyone, and thank you for taking time out of your busy day to be a part of our informational webinar. We have several topics we would like to discuss today, all of which play an important part in the care and operation of your nuclear imaging system. These topics include daily or weekly QC, environmental concerns, common service questions, preventive maintenance, hard drive failure concerns, critical product recovery, choosing a service provider, and service contracts. At the end, our technical staff will be available to answer any questions that you may have. Let's start by discussing daily or weekly QC checks. This is basically a do-it-yourself way to confirm your system is currently running smoothly, and it is also an excellent way to detect any signs of imaging issues. QC checks are also required to stay compliant with ACR and ICANN accreditations. Establishing a regular routine is very important. By doing the same thing on a daily or weekly basis, it is easier to detect even the slightest changes to your system. When running a check, verify your uniformity numbers are within OEM specifications and that they meet the expectations of the nuclear medicine technologists. OEM specification, or numbers as we generally refer to them, are important, and you should always do a visual inspection of the flood to check for artifacts. You should compare today's images with previous ones to make sure no sudden changes have occurred. A sudden change may indicate the start or presence of an imaging issue. You are looking for consistent images and numbers on that daily basis. If you do detect changes, one of the first things to check would be the peak of the isotope. Be sure not only to verify the center line of your peak, but also pay close attention to the shape of the Compton peak. Sometimes the shape of the Compton or the amount of Compton can help direct you to the source of the imaging problem. Another QC check is to perform a bar phantom image. This will check the linearity of the detector. The bars should be straight and visible in the first 3 quadrants of the phantom, and you should also be able to discern bar direction in the 4th quadrant. The environment also plays a huge role, not only in image quality, but in the overall quality of your system. At the top of the environmental concerns is the electric that powers it all. Power quality is extremely important. Power outages are prevalent everywhere in the country on a daily basis. Surges, brownouts, unstable power, and noise can even be more harmful than outages without the proper protection. These occurrences can lead to damage, lack of reliability, or corrupt software files, all of which will lead to increased downtime, lost revenue, and a lot of frustration within the department. Simply adding a UPS can be one of the best investments for your system and can go a long way in avoiding these catastrophes. It is very important to have the correct size UPS attached to your system. When adding a UPS, always check the OEM recommendations to ensure the size recommended or required. The correct UPS should allow any scan that's already started at the time of the outage to be completed and saved using the battery backup. It should still allow time for a proper shutdown to be conducted before the batteries are drained. Please note, it is extremely important to perform the proper shutdown sequence before the batteries have expired to ensure no additional harm is caused. Some UPSs can do more than simply be a backup during an outage. A power conditioning UPS, for example, will absorb spikes, fill in voltage sags, and provide a smooth, constant voltage to your valuable equipment. A UPS should always be included in your camera purchase. At Universal Medical, it is not an option but a requirement that all systems include either a new or reconditioned UPS. Just like your camera, a UPS must be properly maintained to remain in good working condition. This maintenance includes checking all cooling fans and periodically replacing the batteries. 3 years is the approximate expected battery life in most UPS systems. Another environmental factor that can affect QC is improper shielding. Without the proper shielding, background radiation can cause contamination, leading to poor QC, or even more harmful, poor patient images. A small number of departments have lead-lined walls, but the many that don't have several factors to consider. If you are a single camera department, the hot lab, patient injection areas, patient waiting areas, or areas any injected patient may be in, such as a hallway leading to a restroom, are a few of the areas that should be considered. If you are a multi-system department, the proximity to other nuclear imaging systems, as well as any other imaging modality, can have an impact. Having provided service for departments with little or no shielding in the imaging areas, I know firsthand that it can take valuable time or even multiple trips to a facility to pinpoint the source of these improper shielding issues. Additional environmental concerns include temperature and humidity fluctuation, as well as dust and debris that may inhibit cooling of your system. During the spring and the fall, when swapping between AC and furnace units, the temperature issues are at their worst. Corrosion can also be a concern and is most prevalent near the sea, where high levels of salt and humidity are in the air. Even the slightest changes in these variables can cause huge shifts in the function and output of circuit boards and internal power supplies. These changes can have not only an immediate impact on the equipment, but can also cause long-term negative effects. The optical grease can also become damaged by high temperatures. Once the grease is heated, it will be thinner and less adhesive. This allows tube decoupling to occur. Once a tube has become decoupled, it will require the FSC to enter the detector, recouple the tube, and reburn all the QC corrections. Cooling fans are the best defense against temperature variations. Thus, they must be maintained often and with great care. Keeping them free and clean of debris while replacing them when their RPM starts to sag are important tasks. Departments that have dedicated HVAC units for each room where nuclear imaging equipment is present or at least are the least affected by these common environmental issues. When it does become time to call your service provider for assistance, there are several things that you can do to assist in a more timely, less expensive repair. One of the most important things is to be in front of your system and prepared to answer a few questions about the issue and possibly assist by trying a few quick things to either resolve the problem or to determine what, if any, parts should be sent to the site with an FSE. Just a few minutes of your time can dramatically reduce the downtime, especially if we are able to have the correct parts on site for the FSE when he arrives. If at all possible, please try to make that initial call while still on site where you have the ability to assist. We regularly get calls from techs who have already headed out the door, and those can be frustrating to our FSEs and cost your employer more downtime and revenue. It's really not surprising for us to hear things such as, yeah, it gave me an error, but I didn't write it down and I do not remember what it was. And I've also heard it makes an awful noise, but I don't know which motion it was coming from. Knowing these types of answers allows us to have any parts needed on site in a more timely manner. We will always do our best to provide technical support and repair the problem over the phone if possible. We may ask you to complete a series of troubleshooting tasks or open some doors and check a few different possibilities to assist the troubleshooting process. We would never walk you into anything that would cause more damage to the system or harm to your person. But if at any point you are uncomfortable performing the tasks asked of you, just let the technical support specialist know and we will move on to other options to have your system back up and running as soon as possible. Now let's look at some of the most common issues our service team receives repeat calls to assist with. Of these items, we have already discussed poor QC, power interruption, environmental issues, and the steps to prevent them. In addition to those, we also receive several calls pertaining to collision errors, some that don't clear and some that are false. By that I mean they occur when no physical contact has actually been made with the sensors. Depending on the type of system on which they occur, some possible solutions may be removing and reattaching collimators, and in some instances, firmly rubbing your hand across the collimator face may resolve the issue. Network errors causing image transferring issues can be another common occurrence. IT personnel are continually changing network configurations, adding and removing IP addresses, and physically changing connections. These changes often lead to connectivity problems. The first steps in this troubleshooting are to check the physical connections and contact your ID department to ask if any changes to your configurations have recently been made. Motion errors and odd or unnormal, sometimes loud noises made while systems are in motion are a frequent occurrence as well. Checking the area around where the noise originates to inspect for any such debris like dropped coins can sometimes lead to a solution. Knowing your system and the steps or sequence required to reset or reboot can be valuable tools when these situations arise. Protecting your valuable camera and helping to increase its longevity are very important. In an effort to reduce costs and increase profitability, some facilities postpone capital equipment purchases while continue to increase throughput on equipment that is sometimes upwards of 20 years old. In these cases, it is increasingly important to protect your equipment investment and maximize uptime. We have highlighted several ways in which you can assist, whether it's keeping a close eye on your QC, maintaining a clean, constant environment around your equipment, performing low-level repairs with technical support, or just by knowing when to call for on-site service. There is, however, one item that we haven't mentioned yet, and it is possibly one of the most important single items that can be done to protect your equipment and keep it running effectively. That item is preventive maintenance. Let's talk a little about the preventive maintenance, or PMs as they're commonly referred to, and what they mean to the life of your equipment. We all pay thousands of dollars for a car and wouldn't dream of not maintaining it with routine oil changes, tire rotations, and state inspections. So why would you pay hundreds of thousands of dollars for a nuclear imaging system and not plan to maintain it to an equal or even higher standard than your car. Planning for, scheduling, and allowing the time for a thorough PM at regular intervals is basically an insurance policy on your equipment. PMs are also required to stay compliant with any ACR and ICANN accreditations. In addition, PMs are also a great way to ensure patient safety. Patient safety is a huge concern, not only in nuclear imaging, but in all aspects of the medical industry. And unfortunately, it has been brought to the forefront in recent years with a few tragic accidents. Having your system thoroughly checked during a routine PM is the best defense against any unforeseen mechanical failures that could cause any sort of damage to your patients. PMs involve both QC and motion checks and calibrations. Depending on your specific system model, some or all checks and calibrations may be required at different intervals of the PM. It's very important that you know what the OEM specifications and requirements are for your specific model. Please do note that OEM PM requirements can and do change. If a field change order occurs, commonly referred to as FCOs, it is likely that the PM checks and requirements will also be changed as well. During the QC portion, depending on the level of adjustments required, some or all of several corrections may be completed. These include energy cals, spectrum cals, auto gainer tube balancing, and new uniformity corrections, to mention a few. Center of rotation, or COR values, as we commonly refer to them, are values that are also checked and adjusted if necessary. The motion portion of the PM will include checking for noise during any movement and confirming all motion limits are within spec. Lubrication of all moving parts is also performed. From experience, I can tell you that it is sometimes the removal of the old grease, which has become dried out and hard and is now restricting the movements rather than enabling them, and not just the adding of new grease, that is most important. For the electronics, all power supply levels should be documented, all dust and debris vacuumed, including the cleaning of all filters. If fans show even the slightest sign of RPM sag or their noise level has increased, they also need to be replaced. A fully completed PM checklist should always be on-site and available if needed for site inspections. Hard drive failure is a main concern with any imaging equipment. To limit the negative effects any drive failure would cause, there are a few steps that should be taken. Backing up all patient data to packs, copying them over to CD or DVD, or at a minimum, printing them out is very important. Confirming you have all the required software needed, including disks and CDs on site and readily available if a rebuild of a drive is required, is also a must. A document listing all networking information can also save a lot of time and headache. The cost of a hard drive rebuild can be quite high in labor hours alone, not to mention the lost revenue from the downtime. If you are currently using Philips ADAC equipment, CPR may be a cost-saving alternative to consider. CPR is currently available on most Pegasus-based ADAC systems from Universal Medical. Other important OEM camera models may be available in the future. CPR does not back up any patient data, takes less than 30 minutes per drive, and will be a great asset in your time of need. Selecting the service provider for your equipment is a decision that should not be taken lightly. Their response time, both by phone and on-site, are major factors. And once on-site, will they have the parts needed to repair your system, or will they be able to have them shipped in overnight if needed? If you have an issue with applications, or if you have trouble using the system, do they offer support for that as well? Another thing to consider is comparing what items are specifically covered under their service contracts. Glassware and crystal coverages, UPSs, and hot lab equipment are items that may vary among service providers' coverages. As an alternative to OEM service, independent service organizations, or ISOs, can be found simply by searching on the internet and trade publications. Look for a company that has an extensive inventory of parts for your make and model. Find a supplier that you can work with and that you trust. If possible, visit their facility and observe their parts testing and inventory process. Many ISOs also provide hands-on certified training for your internal clinical engineers as well. Don't wait until your system fails to do the research and make these decisions. Have them in place and ready before there is an immediate need for them. Your selected service provider and the type of service contract coverages you purchase from them is also an important decision. There are a few choices when it comes to the type of service coverages that work best for you. Full service contracts will give you the most peace of mind when it comes to service. With them, you know everything is covered and will be taken care of in a timely manner. There are normally options for the payment of contracts as well, such as monthly, quarterly, semi-annually, or annually. Choosing the option that works best for you can also be a relief by allowing their costs to be budgeted. A co-op first pass type contract will work well if you have an experienced clinical engineering department that can handle some of the more mundane issues that arise. PM-only contracts allow you to budget for the required PM services and also allow your FSE to become more familiar with your system, so when other issues occur, he is readily aware of how your specific system should be working. Capped camera coverages aren't offered by all service providers, but can be an alternative when more than a PM coverage is desired, but a full service contract doesn't quite fit the budget. Time and material coverage is always an option as well. My advice, if this is the coverage you choose, is to try to stay with one provider. Simply knowing your system and having a history of what it has required in the past can help to reduce troubleshooting and downtime. That concludes the informational portion for today. Thank you for your attention over the last few minutes, and if anyone has any questions, our Universal Medical Technical staff, including Mike Hill, Chad Watson, Kevin Bohr, and myself, Craig Snodgrass, would be happy to answer them.
Great, Craig. Well, I do have a couple of questions that have come in during the presentation, but I want to take a quick moment just to remind all of the attendees that you can submit your questions anytime using the question feature on the dashboard or even the chat feature using the dashboard. We'll get through as many as time will allow, or we will send all questions that aren't addressed during the live webinar to the presenters offline, so they'll follow up with you as soon as possible. But Craig, the first question that I'd like to pose, you briefly discussed CPR when we have a hard drive crash. Can you provide more detail as to how it works and how we can purchase it?
This is Mike Hill. I'm one of the technical people here at Universal Medical. As we all know, the hard drives are a problematic area in any system. Everything from the hard drive just failing, motors dying, heads crashing, to inadvertent power cycling, things not being shut down properly. Any of those things can cause data to be corrupted on the hard drive. And so CPR was developed as a Windows-based product that allows the users to archive the legacy ADAC Philips, Pegasus, and Atlas systems. It was designed actually as a specialized service tool, and but it is available for anybody to use. The use of CPR requires the end user to install a Windows-based product on a Windows computer. That computer can be a laptop, it could be a desktop in the department, it could be a computer down in the biomed department. Does not have to be local to the equipment as long as it's on the network. Once that system is on the network, the system is configured, or the software is configured to understand about the ADAC piece of equipment or the Philips piece of equipment. You would give it an IP address. In some cases, there's customized passwords that need to be dealt with, stuff like that. Once that stuff's configured, you just simply click go, and the program takes everything from there. It operates over the network, and it archives everything that we would consider unique to that system. As was in the presentation, things that are unique to that system are software, network information, network configurations, software configurations, DICOM configurations, printer configurations, anything that makes that system unique and special from a baseline hard drive. The reason I start from, or I mention a baseline hard drive, is the typical method of replacing or repairing a hard drive is to simply call a vendor, whether it's Universal or whether it's the OEM, and you would say, I need a particular hard drive. They would ship you out a hard drive, and it is preloaded with a base operating system. From that base operating system, everything else is added, whether it's network configurations or software or whatever. So CPR, again, simply has archived all of that special stuff and is able to put it back. As Craig said in the webinar, it is really, really important to have access to your software. If you don't have your software CDs, if you don't have your network configuration, if you don't have your DICOM information, it can be extremely, extremely hard to ever try and locate some of that stuff. Sometimes, in fact, you can't locate it, and you have to find some way of getting backup copies or purchasing it again. With these systems being in existence for on the upwards of 20 years, things get misplaced often. So CPR's job is to eliminate some of that, or actually can eliminate all of that concern. Since it does back up all of the software on the system that is unique, it does back up DICOM, AutoSpec Plus, AutoQuant, everything that is unique on that system gets backed up. It does back up the network configurations. And the most important part of that network configuration information is in a, if you're an ADAC person, the master-slave relationship. There is a binding that takes place between two systems, and that binding is very, very specific. And so even though I might put another hard drive in, if I don't recreate those bindings, then it will not understand that it can talk to the other computer. So CPR not only puts back all the software, all the network, all of your DICOM, all of your processing protocols, display defaults, everything. It also puts back the bindings. So your system will go from a broken system where it doesn't understand the rest of its network to a complete restored system. And as Craig said, typically in under half an hour for the restore process, from the point where you click go and it starts putting the data back to the point where you're rebooting the computer and it's functional again. There are usually some small things that have to be dealt with. CPR does not back up patient data. It specifically does that to keep it HIPAA compliant in case the data set is taken off-site. Therefore, we don't have to worry about HIPAA problems or any of that kind of thing. So the patient database would need to be reconstructed, but that is a very, very small price to pay. And as Craig said, hopefully we have backed up either to PACS or to a CD or to magneto-optical or to some other method all of the patient data that is needed, so we have our patients. If you've ever built a Pegasus drive before, it can take 4 to sometimes upwards of 8 hours, depending on the complexity of what we've got going on. And that is with everything in hand. That is with all of the software in hand, all of your network information in hand. It can take a long time. Compare that to half an hour to an hour, and you can see the benefit of using a product like CPR to back things up. As far as where it can be obtained, just call the office and talk to somebody here at the office, whether it's Craig Diener, our product manager, or Jason Kitchell, he's one of the owners. Basically, almost anybody here at the office should be able to direct you to somebody that can help you with CPR.
Great, thank you. We have a couple of more questions. I'm just going to pose them to the panel. Please speak up and identify yourself if you're going to be the one answering. When I have a collimator collision, how do I determine if it is an actual true collision or if it is false? And what are the quickest steps to determining what happened?
Hi, this is Chad Watson. First, let's talk about the circumstances around the collision. Was the camera sitting idle and when the collision occurred, so you left the room and came back and seen the collision, or it came in first thing in the morning and the collision was there? If so, can you clear the collision? If it clears and you can go on about normal use, it may have been a false collision. If not, what were you doing when the collision occurred? Were you manually moving the camera or doing a pre-programmed motion? Things shift during motions and can cause constant collisions. Things like collimator movement can lose contact with the ID board, or cable positions change and there may be a loose connection or a broken wire that shifts and causes your constant collisions. Also, did you witness a physical contact of any kind with the sensor? Was there patient interference, contact with an stand or a step stool or another object? If so, this could cause damage to the sensor. So these are a few questions that might be asked, and if you know the answers to these, it can help with troubleshooting and determining if a service call is needed.
Great. The next question is, we have a constant issue with our QC numbers being high and on the verge of being out of spec. It seems to be caused by background radiation that we can't find and eliminate. What can we do to avoid this issue?
This is Craig again. There's several things you can do, and this is something we run into on a daily basis. One of the main things to do is when you start your daily, check your peak. Make sure your peak is on, and that can lead to letting you know if there is any background. Without putting your source out there that you're going to do your QC with, actually start a QC check and see how many counts per second you have. Normally, we'd like to be under around 300,000 counts per second, or I'm sorry, 3 million, or 300 million counts.
300.
Just 300.
Or 300 counts, that's right. We'd like to be under 300 counts per second. Anything over that can really cause some background issues. So again, 300 counts per second is where you want to be. If it is above that, then you need to do some looking around and see what you can find. You know, check your source containers, and by using a lead apron or using one of the roll around lead shields, you can kind of put them in a position to direct where you're facing, and that might lead you to where the background is coming from. In some instances, we had one instance I know in another state where it was pointed at an outside wall. The wall it was pointed to was an outside wall. There was nothing that we knew about that area, but we got high background every time. So the only thing we could do was rotate the camera and point it in a different direction. And that's also another good thing to do, is rotate your camera around and see, you know, do you get it while pointed straight up? Do you get it while pointed at the back wall? Because if you're getting it everywhere, then there might actually be an issue with your system, that it's got high background counts. But if you only get it in certain directions, then yeah, it's got to be picking up something. And again, shielding with a lead apron, things like that. Check for sheets. I know we've run into that a lot. Old sheets in the laundry basket that just happen to be setting in the direction the camera is facing. And whether they've been soiled or whatever can sometimes have some radiation on them. And that can also cause a problem. Sharps containers are another thing, hanging on the wall, or even just a trash can. Sharp containers are very often can be the cause, but even just trash cans where things are thrown away that might have a little bit of activity on them, even though they shouldn't be there, occasionally they are. Double checking for anything like that around the area can be a good way to track things down and figure out what's needed and where it's coming from.
Great. The next question from the attendees, what about bit-by-bit copy of hard drives yearly?
A bit-by-bit, this is Mike Hill again. A bit-by-bit copy of a hard drive can be a good thing to do. There are some things you need to watch out for or worry about. When you're doing a bit-by-bit copy, obviously I'm taking all of the data from one drive and I'm putting it on another drive. If you inadvertently tell the source drive that it's the destination or the destination that it's the source, what happens is you take the drive you want to copy onto and you take all of its junk data and pile it on top of your good data, and now you've got no data. Your drive is completely corrupted as far as its use for you. So it requires care in doing that. The other issue about a bit-by-bit copy that you really need to be concerned about or worry about or take care of is ensuring that if you're doing physical connectivity, I am removing hardware from a system, so I'm going to have to physically remove that hard drive from the system and put it either on a machine to do my bit-by-bit copy, or if you use a command like a DD command on a Unix system to do a bit-for-bit copy, that is something that you can do also, but then you're installing a new hard drive onto the system. And so in either of those cases, again, we're talking about physical interaction with the equipment. Anytime you touch something, anytime you start playing with things, you can inadvertently cause problems. If you jumper both drives as being master, or if it's a SCSI drive and you set them to the same ID, you can end up with unforeseen circumstances or things that you didn't really know. The last thing that is of real concern is, do you know that your original source is valid? A bit-for-bit copy works great when what I'm copying from is good, 100% good, not 99% good, but 100% good. If I have a problem with my drive, if there are areas that it can't read, then the bit-for-bit copy is going to fail. Depending on the product or the method you're using for the bit-for-bit copy. Let's say that I'm using the DD command again. That command sometimes can be a little cryptic about whether it finishes. I can do a DD command. It can start doing the bit-for-bit transfer, and it will tell me that at the end it will say, this many blocks in, this many blocks out, and I think everything's great. What I missed was just a little message that it said it had a little bit of a read problem. Well, so did it really copy everything, or did it not? So unless you're really familiar with it, using the DD command and specifically, you can run into problems. If you use an external device, a drive duplicator, a lot of times those do have a fairly good diagnostic type screen for you, saying, hey, I got problems, you got problems, this is not going to work really well. The last thing I can think of as far as bit-for-bit copies go, you really need to be careful about doing a bit-for-bit copy if you are a independent service person. If I'm an internal biomed person, hey, I'm good. I work for the hospital. I am doing the bit-for-bit copy at the facility. I am keeping the data drive at the facility. And the reason I say that's important to think about is when I do a bit-for-bit copy, it is copying patient data. as well as programs, softwares, configurations. And so that patient data now is a HIPAA liability. If I am a independent service group and I walk in and I say, I'm going to back up your system, and I do a bit for bit copy, and I walk out the door with a duplication of your drive, I am violating HIPAA. And now we all have problems. I'm violating it. You've let me violate it. We're all in trouble. Now, if I go in there and I back it up and I tuck it away in some little corner of the room or the equipment where I can access it later, then, you know, we're good. You need to think about things like, you know, patience. Are you familiar with the method that you're using? You know, is this the first time you've used it? How comfortable are you with what you're doing? There are just a lot of things, but bit-for-bit copies definitely can and do have a place.
Great. We have a couple of more questions. I believe we have enough time to get through 3 to 4 more. You mentioned that the standard PM procedures can be changed by the OEM. How would I know that the PM procedures have changed?
Hello, this is Kevin Bohr. An example of this is when GE had an incident in the Northeast with one of their systems. They sent letters to all of the customers with the affected equipment to everybody in their known database of customers, notifying them that the incident had happened and that because of that, the PM procedures were changing and that they were to go get the latest revision of the manual, which is available online, and follow the new procedure, not the old procedure. So that's one example. The other is if there's mandatory field inspections or retrofits, the OEM should send letters as well to their customers. They should also send them to companies like us so our customers are aware and we can then send the information along. Sometimes that works in reverse, unfortunately. We find out from existing customers about it, but the OEM should let everybody know that it has an affected piece of equipment.
As the service manager, I just want to let you know that if we do hear of anything, we do pass that on to all of our customers immediately, so they're aware. And of course, we would make changes to our PM procedures and the PM checklists that we provide at each PM, so that, you know, they're all up to date and cover everything needed to properly document a PM at that point.
Great. Next question. Weather can be a little unpredictable where our hospital is located. What would be the impact if we didn't have a UPS and lost power suddenly?
The impact can be, this is Mike Hill again, the impact can be anything. And that's the unfortunate thing is there is no predictor on this. You can lose power 47 times and life is good all 47 times. On the other hand, you can lose power 1 time and you can have anything from when the system starts coming back up, you blow a power supply, to when the system comes back up, it wasn't shut down properly, now my hard drive's corrupted, to anything can happen. And that is really the unfortunate thing about power issues, whether it is a spike, whether it's a sag, whether it's just a plain old outage. It can really hit you hard. And it's I like to liken it to roulette. You know, you roll that roulette wheel and you don't know where that ball's going to land. And every now and then it lands and you're in trouble. You know, you might have a good run of luck and you never have a problem, but it just takes once for it to be a real issue. And if you really think about the cost benefits of things, you know, I ran for 5 years and I didn't have a problem. But the one time it happened, you know, it cost me a day or it cost me 2 days because I have a day of down, somebody's out there troubleshooting, they had to replace a hard drive. Hard drive gets shipped the next day, so then I'm essentially down 2 days. I've got 2 days of revenue that I've lost, or that the department has lost. And how much is that revenue versus a UPS and just replacing the batteries on the proper schedule? If you look at the cost, it is much better to keep those UPSs running, functional, and properly maintained than to gamble.
It doesn't have to just be weather issues either. Especially some of the bigger hospital facilities are constantly doing construction, whether it's in the hospital or outside, and that can really interrupt power as well, whether they mean to or not. Hospitals also do random, well, not always random, they're usually scheduled, but still they do tests of their own backup generator equipment. Some of the imaging are not on that backup equipment. That's a possibility as well, but even if they are, that power may not be as clean or as good as the actual normal power. And yeah, at that moment when they switch over from one to the other, there's always that momentary break that can give a surge or an output or a spike just for that instance. So things for that, just for those, are important as well. And across the country, and we run into different portions of the country. I'm going to throw out Las Vegas as one. We've had lots of trouble with the power in that area. For us, anything we put out there, we put a conditioning UPS on simply to clean up the power coming out of the wall, because historically we've had issues out there with bad power. So, and that varies across the country, but like I was saying, there can be all kinds. It doesn't have to just be a weather issue causing power. It comes from several different areas.
All right, guys, it looks like we have time for one additional question. In general, what is the parts availability for a 10-plus-year-old system?
This is Chad. That's going to vary depending on what system it is. A lot of the older ADAC equipment, the parts are more readily available. Some of the other OEM equipment may not be, so it just depends on the type of the equipment. The OEMs do end of life on their equipment, so they may not have anything for you, but a third-party company such as us would still keep those parts in-house and tested and ready to ship out.
As far as we're concerned here at Universal, I mean, we go back on the Siemens line. We have several orbiter parts. That's one of the older systems. On the Philips side, we go all the way back to the single and dual head gens, the Argus, even some ARC 3000 parts, which are even getting farther back than most of us like to remember. Down the GE line, Millennium MGs, we have several parts for those, and anything since then. But that's just kind of a rule of thumb as to what we have around here. Other parts for older systems can be sourced if necessary. So.
And different ISOs tend to specialize in different products. We specialize in mainly Philips. We do a fairly good Siemens and GE. We keep a fairly good stock of Philips and GE stuff, actually quite good stock. But there are other people who, GE is their bread and butter. That's what they mainly do. And then there's other people that Siemens is their bread and butter. That's where they focus their efforts at. So even if we aren't able to get it, or, the other ISO isn't able to get it, somebody is almost always able to get a part for you without having to go to the OEM.
Probably a better way to say that is, even if we don't have it, or the one you're working with don't have it, they can source it from another provider to come up with the parts needed.
Wonderful. Thanks, guys. Those are great tips, and we appreciate your answers for the Q&A section. Also, I want to give a thank you to Craig, our presenter today, and of course a big thank you to the sponsor, Universal Medical. One lucky attendee will win an Amazon gift card for completing the post-webinar survey. The survey will appear on your screen shortly. You must complete the survey to obtain the certificate of attendance. If you do not see the survey, please email us at webinar@mdpublishing.com. We do have upcoming webinars posted on our website. You can see a complete calendar and free registration at technation.com. Again, that's technation.com/webinars. Enjoy the rest of your afternoon, guys. See you next week.